Alright, so we all remember exactly how to do these. Right, so having looked at straightforward questions where it's just cos x equals a number, or sin x equals a number, or tan x equals a number, we now need to look at a little bit more complicated stuff. So, do we remember what does the graph of sin 2x look like compared to sin x? No, shorter? It's actually compressed. Now, your initial gut reaction was, I believe, talking about 2 sin x. Do you remember? Because this number here changes the, what's it called? The amplitude. Good. But for sin 2x, that's the one that changes the period. Okay? So for a normal 360 degrees, how many sine curves do we have within the normal 360 period? How many here? 2. So secretly what's happened is that your period is reduced to 180, and so it's going to do that within 180, and so it's going to happen twice within 360. Okay? Well, what's the point with that? Well, the thing with that is that it's not usually in our radius we're looking at 2 solutions, but if we were looking at the same 360 period for these graphs, how many solutions would we have? 4. Right. So, if we usually take 2 solutions, how many solutions would split times 2x? Now, what we're going to do here, so this is my way of doing this. That's the way I do it. Anyway, so our question is sin 3x equals 0.7. We're asked to solve that. I'm suggesting that we're going to, rather than stick with this, I'm going to change it to just A. It could be any letter, it doesn't matter what it is. So I'm going to go back to what we were doing previously and just solving sine something equals 0.7. And how would we do that? What's our first step? Sine minus 1 is sine negative 1 is 0.7, and that's going to give us A, yes? And let's chuck that in our calculator, shall we? Oh, here we go, let's go. Right, so we've got 44.4 as our solution. And what do we do then? We know it's a 0.7, so we draw a line around 0.7. And so we've just found this bad boy, yes? How do we find the other one?
Oh, you would just do 180 minus.
Yep. And that gives us... Yes. Okay, so we've got our 2 solutions between 0 and 360. But this is where we have to revert back to that. Well, that wasn't the question. The question was sin 3x. Okay? So for a sin 3, or what have I written down? So as I said here, now think about how many cycles will take place in sin 3x compared to what? Sin. Well, how many cycles?
Oh, cycles.
3. So there's going to be 3 cycles. In other words, there's going to be 6 solutions. Yes? Now, you've got 2 different options here. My preferred option would be to get it right. So we know that A is 44.4 and 135.6. If I know I need 6 solutions, what I'm going to do to this is find the next 6 results. And what was our method to find any more results? Add a period. So we're going to add 360. Okay, so we're adding 360. So then add 360 to both of these 2.
Are we going to use A, B, C, D?
No, these are all A. Because we found sin A. 404.4. And then we can do that again, yes? We can add 2. 7, 6, 4. chooses. Now, looking at those, it looks ridiculous, doesn't it? Because they're way out of our range. But what did A represent? 3x. Okay? So if that represented 3x, what do we now have to do with all these numbers? Divide them by 3. So that means our values for x are going to be... I'll pause for one. So dividing all of those numbers by 3 gives us these values here. And they are all within our range of 0 to 360. Okay? Now, your alternate would be to have these two first solutions, divide those by 3, so you know that your values are 14.8 and 45.2. And then you could add your new period to those. Okay? So our new period would no longer be 360. It would be 360 divided by 3. So our new period would be 120. So what we could have done was found these two and then kept adding 120 to both of those. To all of those solutions. So you've got a choice. I tend to like this one just because it keeps you in the system that it used to by just adding 360. But it's completely up to you because some people just are like, well, why am I making this so weird? Okay, choice is yours. Alright? And I think that's what all of these words say. So let's start with cycles, there's multiplication. These divided up 3, actually. And then okay, good? Alright, another type of question you might get would be one that looks like this. So this says 4 cos x equals 3. What should we do with this? Well, first, what you should do is figure out what does affect the answer? Yes.
But we don't want that yet.
We don't really know how to solve for x. So what could we do with this?
So let's minus 1.
Not yet. We could rearrange it, yes. Because what does this mean? This means 4 multiplied by cos x is 3. Yes?
Divide by 4.
So, yeah, so we can have cos x equals 3 cos x. And now, our value of cos is less than 1, which is what we're expecting. So now we have that cos x is 0.75 for decimals. And now we can go into the minus 1. So we can say, we find that first solution. And then we would draw our line at 0.75. We found this one at 41.4. How do we find the other one?
Where's
from 36 or 36? Yep. Now, obviously, all these numbers, they're a mixture between 3 and 4 significant figures. When you use your final answer, just make sure you're writing it accurately. And so there are 2 solutions within that range. Okay, so sometimes it may involve you rewriting more of this. Sometimes it's going to involve a lot more rearrangements. Okay, so how would we rearrange this bad boy? So add 2 first of all, so we've got 6 sine 2x is 3.
according to Ben, divide by 6.
Divide by 6. Yes, Maddie?
How was I going that far?
Because remember, to solve something, we're working dead mass in the opposite direction. So you're dealing with any addition, subtraction, division, multiplications before you get to powers or brackets. I'll just have them.
Oh, yeah.
Did I pass?
Yeah.
Because then continue teaching.
Sure.
Cheers. Now, this one is assigned to it. So this is where I would use that method of saying, well, I'm going to change it now to say that sine A equals 0.5. I'm going to solve for A, but I know I'm going to have the double the number of solutions. Now, I can't stress enough that sometimes these could be on a non-calc paper. So you may be required to solve things like this without the calculator. So you've got to remember those triangles. So you find A is ready. Do you remember that? And so this bad boy is 30, and then how do we find this one here? Minus that from what? 180 subtract. Remember, you're looking at your symmetry. So that would be 150. So we know that A is 30 and 150. We know we need double the number of solutions. So we're adding these on. Oh, that's not 360. 4, 5, 10. So there's our 4 solutions. But that represented 2x. So to find x, we're going to divide them all by 2.
So that's 15. That is 75.
Is that right? No, it's not 1.
45. Half a minus 45.
But it's 390, darling.
Oh.
Jesus. Okay? I don't know why.
So what did you add to 150 to 390?
No, I added 360 to both of these two.
360 to both.
So 360 is that, and then it's that,
Oh, gotcha.
Yeah?
Yeah.
So remember, once you put the first two, they're the ones you focus on, and then you're adding 360 to both of them. Okay? But it's pretty straightforward, yes? So it just involves a little bit of rearrangement, or just recognizing that you've got more solutions. So let's practice. Alright, so this is one example. So what do you think we're going to do with this bad boy?
That's root the 1.
Root the 1. Okay, so we're going to add 1 to both sides. So we've got 3 tan squared x equals 9.
Right. Okay, and then I want to divide by 3.
Let's do that. So tan squared x equals 9 over 3. So tan squared x equals 3.
And then some logs. No. It looks like a log fraction.
Well, remember, so when the squared sign is in between it, secretly that means tan x is squared. Remember?
Okay, so you take square.
The reason that we don't write tan x squared equals 3 is because that may look like it's tan of x squared. Okay? So to show that the whole of tan is squared, that's why they write it in the middle. So as so it's got squared, so once it's squared, what do we do? We square it. So that tan x equals plus or minus the square root of 3. So for this one, you're going to draw your tan graph and okay, so we're going to draw our tan graph and we're going to have it at root 3 and minus root 3. So you've actually got double the amount of solutions here. Now I'm not going to do that one with you because the next steps are the things that you need to deal with. But just remember that when they're squared, when you square root them, you've got both the positive and the negative versions. Now there's another type down at the bottom. That is an X. It's a very clear X. Very clear. I believe. The other type is if you look down at the bottom of number 3. Let's do this one.
Oh, well, that's an additional third one.
So down at the bottom, there's 7 of them. I just picked one. So we've got sine squared x equals 6 sine x minus 5. Anyone want to hazard a guess what we might do with these?
I think you need to put the signs along. No, okay, subtract sign, blah, 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 and then back to that. That's just what I was doing.
You want to put this with this?
Yeah, but that one over here are
But you could do that, but I was just watching something else. Anyone? The format of this look.
Quadratics!
Oh, yes. So the format of this.
Why did your face light up so much?
Mine?
Yes.
Because she got it.
Shut up.
So sine squared x, you've got a sine x, you've got a number. So that's in the format of what we would normally think of as a quadratic equation, yes? So how do we solve quadratic equations? It has to equal 0. So actually everything is going to be moved to the same side. We're always going to be sine 2x sine.
How can you move? You would the sign squared x1.
Because normally our x squared problem. Yeah?
This is my thing.
Did you write something?
I was on the fast.
Alright, so now we've appreciated it's in the format of a quadratic, but having this sine business, so again, I would probably say I'm going to, instead of writing sine x, I'm going to write a or b, doesn't matter. So this would now be written as a squared minus 6a plus 5.
Okay.
Again, as I said, the letter really isn't important. So I can finish it off. And then we would solve this as we would for any other quadratic. How do we solve quadratic? Could say factorize, yeah? Remember, it's a knockout. So we've got A at the front of both. How do we start with this again? How do we decide what they are? Let's multiply digits. 3 multiplied by 2 doesn't give 5.
5 is 1 No, 5 is
87.
minus 5 minus 1.
Why is that case? Multiply to positive 5 and add to negative 6. So
You move good.
yeah, with everything. See now, these kinds of questions, they bring in a lot of recollection from other topics too, so they're quite common because they do challenge you. So obviously here this means that A is either 5 or A is 1. So if we know that A represents sine x, so we would say sine x equals 5 or sine x equals 1. Now at this point, some of you should, some of you may be more remembering than others. Is there anything wrong with anything written there? It can't be more than 1. So which of these must we ignore? So we're going to ignore this bad one. Awesome. Okay, so we're going to ignore that one because it's impossible. And we're just going to focus on the sine x. Now, that's all we're going to have. You may have two solutions that are both possible. Okay, but if not, then you just focus on the one you have. It's a straightforward sign X, so we've got our 91, 87, 60. Where is this one? Just here, so we know it's just one. Okay. Now, as I say, I chose a slightly easier one because the others have coefficients in front of the squares, so that you would work them out just the same way as you would in the work. So you factorize, split them in terms, etc. Okay?